Without further ado, since we've got a really packed lineup, I want a very warm welcome to Daniel O.
Thank you. Thank you. So welcome to, is that okay? The mic? Okay? Yep. Yeah. Welcome to Supersonic Java Quarkus with the Knative Serverless. This is a really super cool because the normally in a cloud-native architecture and cloud-native application environment, people keep saying what is the best way to build, design, and deploy and manage your microservices or cloud-native application. So today, I'm going to really talk about what's going to be best, your Java application into your cloud-native architecture. So my name is Daniel O. So I'm working for Red Hat as the technical marketing major and specialized cloud-native application app dev and DevOps and Agile practice. And also out of Red Hat, I'm a CNCF ambassador. So if you are really interested about CNCF project like a Kubernetes and Envoy proxy and the Prometheus, just let me know. So I'm going to talk a little bit about the developer journey. So I was Java developer for many years. So many years ago, we have only one this Monolith application. Pretty big and heavyweight, but it was really good because you have in the Monolith application, you have 100% functionality, capability, and you don't need to worry about some dependency and reference, etc. But there are many obstacles and issues to maintain this Monolith application. For example, if you wanted to change a small piece of your Monolith application, you need to figure it out the rest of them, like a regression test, a performance test, even functional test. You need to do that continuously and hold everything. So that's why the developer just get started to break down your big Frankenstein Monolith application into small piece of modules. So you have a problem module, maybe you might have the file component module, but still you are the multiple module package in one single application artifact, like a Java technology. We can call that a WAR file or EO file or some Java file and running on the big heavyweight middleware. So the microservice was born to fix this kind of problem. So now you have a single module can be running on single independent runtime like a Spring Boot, Node.js, and Vertex, etc. And you might have, and actually necessarily, you will jump in the cloud-native architecture like Amazon, Google, Microsoft, or even the private cloud. So now your microservice application have a very complex network devices or network services, something like this. And now your microservices might have a multiple entry point, like from the other application, RESTful API, or IoT sensors, or even some end user web browser or mobile devices. And also, your microservices might have multiple data sources, like the relational database and the MongoDB, like a NoSQL database, even data grid, like a multiple district data grid. So now our Java developer and the developer arrive in function error. So back in maybe 10 years ago, maybe still, unfortunately, many enterprise developers still continue to developing the Monolith application, but they call that we have microservices, but that is not true. So some developer or some enterprise companies already arrived in function error. Maybe people really interesting about the Amazon Lambda or Google function and the Microsoft function as well. So at the developer point of view, so how it works, the functions. So you have multiple events from RESTful API, from IoT sensor, from web browser, from mobile devices. This whole event called single function. That single function trigger your backend application. We can call that microservices or a cloud-native application. So I got many chance to talk about this agenda with many enterprise company in the application architect and the enterprise architect, and also the senior Java developers, and how they people imagine the serverless computing. So most answer were Amazon Lambda, because you don't need to worry about the backend application and backend infrastructure, or resources, CPU, etc. You just need to create the application like Java, Python, Go, Node.js, and package that application artifact and upload, and the others will be done automatically by Amazon. But there are two big challenges if you adapt and if you manage your serverless application, the address your function or simple microservices as a serverless workload. There are two big concerns to maintain. The first thing is you don't need to, you cannot building the multi-cloud strategy. More and more enterprise companies already moving the multi-cloud strategy in order to avoid some single vendors lock-in technology as well as the more hybrid cloud. And second thing is for application side, there are some limitation of application dependency or languages and framework. So in microservice architecture, there's no limitation to implement your business requirement with multiple runtimes. But if you adapt to just a single cloud provider to manage your serverless application, maybe not gonna happen. So what is the solution to solve this kind of problem? Maybe answer is maybe easy, just manage by yourself. But luckily, in the meantime, we have many great technology and framework to make it easier, make it simpler, but still not going to be hard. So Linux container from Docker container, but now we more have standard the OCI format containers. And Kubernetes is a de facto the container orchestration platform. I believe you are already have many experience to play with the Kubernetes platform. And it's still service mesh. So maybe 2013, we have only one microservice architecture in the cloud based on Spring Boot application and also many Netflix open source projects like the Eureka and the Ribbon and the console, etc. But this a whole bunch of things is not about your Microsoft application functionality. It's all about non-functionality like a smart routing or the fault tolerance and the deployment strategy, etc. From now, the Istio service mesh is kind of dedicated infrastructure, aka Envoy proxies sidecar container will take care of all non-functional capability to maintain your microservice application. So all in modern application, architecture API is not an option, it's mandatory. But still, Kubernetes is really not easy for developer. I got a quick, some funny example. So just 2 weeks ago, I met one of the enterprise architecture team leader, and he really want to develop microservice application based on Spring Boot and run Kubernetes and like immutable infrastructure. But he got some big problem to change one single line on YAML file, but turns out he took more than 3 and 4 hours to figure it out. The problem was there one single indentation is wrong, maybe one indentation put in some developer. So YAML file format looks similar to JSON format file, but it's definitely different to work. So that's why the Knative came up to help the developer to create microservices for serverless application. So Knative is based on Kubernetes platform to enable the Knative enable Java developer to build, manage, and deploy your microservice application into Kubernetes as a serverless application. So here's 3 primary components of Knative: build, serving, and eventing. So actually, build is already moved in the Tecton project as a part of the cloud-native CI/CD pipeline. And the Knative build enable Java developer define a multiple step, multiple strategy to build container image based on your application. And serving enable you to create, deploy your application, but you will have the exact serverless capability. So for example, you can define some interval, for example, 30 seconds, which means that if there are no requests from some end user to your serverless application during 30 seconds, that application will be scaled down to 0 automatically, just like serverless capability. And eventing, someone just want to create a provider, and someone wants to create a producer and consumer, and eventing make it easy bind and wire between producer and consumer. And even Kafka event is one of the popular distributed streaming platform. Kafka event enable the Knative eventing component as well. So today I'm gonna just a little bit talk about Quarkus. Quick question: how many of you have some experience or even heard about for what Quarkus is? How many of you have? Please, hands on. Oh yeah, yeah. It's a pretty worse. Yes, I just keep talking about the infrastructure side, like Knative and Kubernetes, and many stuff is more focused on infrastructure layer. So what about application side? Because in this era, many enterprise and many people really interested about the DevOps and DevSecOps and something like that, agile practice as well. So what about application side about serverless, even more Kubernetes native stuff? All application runtime, including Spring Boot and Node.js and Vertex, came up for container technology and Kubernetes technology, which means specifically Java technology is a keep fighting with the optimizing resource and some the file and etc. to run immutable infrastructure like a Kubernetes. So another the Java application some issue in this immutable infrastructure era. So keep application needed to evolve to cloud-native application and microservice and serverless application. Problem is we don't need to reinvent our existing application to serverless or cloud-native or a microservice. We just need to implement our application just one time, but deploy serverless or deploy to microservice and cloud-native. So I'm going to show you a quick demo about Quarkus and Knative and Kubernetes as well. So one of the easiest way to get started to develop Quarkus application, actually we have Quarkus.io. It's invented by Red Hat, but this is just open source projects, and anyone can use that. Here is the Quarkus.io. Here's the Quarkus project, how to get started, and some practical and helpful example. And here is the, once you click on Start Coding, oh, yep, here. Yep, if you have some experience to develop Spring Boot application or Spring application, maybe you are familiar with the Spring Initializer. It's a really comfortable website to generate your skeleton code. For example, I want to do some REST API JAX-RS, or I need some the database transaction dependency. So here is a similar thing, but more than that, maybe you can add some JAX-RS, Jackson, and REST client, and generate your application. And you can download some G file and extract that file and get started to develop with your preferred IDE, like a VS Code, IntelliJ, or Eclipse, and any other IDE tools. So today, actually, I already downloaded one of the example. So here is the Java application. Actually, from that the start code, the Quarkus website, but I just a little bit tweak to save time for demo. And I'm going to use the VS Code to demonstrate this demo here. All right. Once you open your IDE tool, here's the PalmXML. So if you are a responsible developer, specifically Java developer, maybe you are so familiar with the PalmXML and maybe the project architecture. So here just some the Quarkus dependency here. And that is the, here is, we're going to use the Maven plugin to build. I'm going to show you that how it works as well. And here is the, we use the native profile. So one of the beauty of the Quarkus, you can build your application artifact like a Uberjar and running on JVM. And also you can package your application with the native image like Go program language and run on top of the GraalVM rather than JVM. But what is the benefit to run your application on GraalVM? It's a really fast and a small memory footprint. I'm going to show you that thing. So here is the simple, the REST endpoint Java application here. So I just put in some skeleton code. Here is the endpoint here, the hello, and return hello. So let's say, yeah, this is my simple application. Maybe I'm already done the application. So how to make sure if your application functionality are working here? So using the Maven plugin. So just get started, this application here. So we just need 1.4 seconds to start up the Java application and go back to here, the web browser and the localhost 8080. So here is our landing page. So how to get started and welcome to Knative application ready. And we're gonna go to the end point here, hello. And I'm going to zoom in a little bit more. All right, hello. So let's change the code, just like the developer, the daily work. So I'm going to change the return code simply. Welcome Quarkus on Knative. And I'm going to save. And try to reload the web browser. So just change that, the application. But the beauty of the Quarkus, I don't even restart and redeploy and repackaging my application. Just one thing I did, just reload my web browser, and that triggered the repackaging, redeploy, and restart all application in here. And I just needed to here to 0.6 seconds to make it happen, just like that. All right, just start my local runtime here and just to make sure the server is down here. So next step is I'm gonna depackage my application. Let's say I already done to implement my business requirement to run my simple single application on Quarkus. And next thing is I'm gonna create a package file like a jar file. Maybe people know that Uber or Fetcher. So Maven create. So using the Maven plugin, packaging, I'm going to skip the unit test because I already changed the return value, which means it's going to be error because the unit test expect the return hello, but not, we already changed the return value. So already done, just to make sure here, so we can see. So we're building Java file here. Okay. But for running the Uberjar here, I'm going to just put in on the active monitor my local MacBook Pro, and here is I'm gonna just wanted to show you the memory footprint. If I run, this is the Uberjar. So this is the default for the application, Java application. And once I run here, okay, this is the other one. Target here 3, okay. Target and the Quarkus here. All right, it's running. We just need to just half a second to run this Uberjar application back to web browser, and just make sure the server is up, and back to the monitor here. So now we have this, this one, almost 96 megabyte as the memory footprint. Okay, so next step, so now we make my own application artifact based on Java application. So next step, to deploy this application to Kubernetes, actually we're gonna use Knative serving, but in order to do that, we need to containerize this application like a Docker format or OCI format, container image. But for that, I'm gonna packaging once again as the native executable image. It's a more small memory footprint, and also really super fast to start up. So using native image, the same using Maven Korean package, but this time I'm going to use the profile native. It takes a couple of minutes because traditional Java technology is using just in compile strategy. So all required tasks such as the annotation scanning and the parsing descriptor and the loading the memory, the class file, it will be happening at runtime. But during the packaging native image, all that dependency, all that task, we're gonna do that in build time, not runtime. So that's why it's gonna takes a couple of minutes. So, and also this native image can be running on the certain machine where you package the native image. So for example, I'm just packaging the native image on my MacBook, which means this native image file can be running on the MacBook Pro, not Linux operating system. So I just show here, so file type here, so MacBook, so which means maybe and also there's another way to packaging your native image based on Linux operating system as well. I'm gonna skip that thing because I already made that thing and also save my demo time. So how to run the executable image? It's like I said, it's executable image. Just run that file itself. So here, the target directory. So now we have here the runner. Here, yeah, see that? This is some security in my local machine here. So we have just 10 milliseconds to run this application. So people really love to Spring Boot and the other Bootx or Node.js runtime because it's really fast. Just 2 seconds, just 5 seconds to run my application. But this is maybe 10 times, maybe 1,000 times faster than that application. And back to here, just reload the application, it's working. And activity monitor. And I'm gonna show here, the runner. So it's a 7 megabyte for memory footprint. So Uberjar, we have almost 90, but just 7. So just imagine, I'm not saying you needed to change all the application runtime to Quarkus framework, but it depends on your use case. Maybe we need to deploy our microservice application to Kubernetes, but we have maybe 100,000 applications. And also, we need to save the memory footprint. We need to save file size. We need to save the network bandwidth. And also, we need to deploy this microservice application as serverless. So point is, serverless application start up really fast. Even end user doesn't recognize this application already scaled down to 0 and click on some web browser and scale up automatically, but it's just happening 1 and 2 seconds. Okay, the last thing is, I'm going to already run my local Kubernetes cluster. It's an OpenShift container platform here. So I already deployed that, the primary component of the Knative here. So for example, Knative serving here, and the workload here, the application already deployed here. So one notable thing is Knative here. I already mentioned the interval stuff, configure map here, the configure autoscaler, and now here. This is the default interval to 30 seconds, meaning is if you have any request from end user or the other application, REST API, it's going to be scaled down to 0 automatically. You can change that this value. Okay, here is I have just one YAML file, so it's going to be generated from the our skeleton in the start code Quarkus.io. So Knative as
default
uses the Kubernetes custom resource definition, and I already push our native executable image into OpenShift Kubernetes cluster to save time. So when I just make sure the current project, back to here. So I already created the empty project or Kubernetes namespace. Here is there's nothing here, and I'm gonna split my. Okay, kubectl here, and just apply this service YAML file, and here kubectl. So there's nothing in here. I just click on the create I just try deploy this Quarkus native executable image, already containerized that thing, and try to deploy, just create here. So actually, I'm using my mobile phone tethering because there are some limitations to access my cluster using the security port. So back to here, local environment here. All right, quite slow. So I have a couple of slides deck here. So let's see just a couple of minutes later. So just a couple of benefits of a Quarkus application for cloud-native application development as well as a serverless application. So you already saw just need to just a couple of seconds to redeploy, restart your application automatically. It's going to be increase the developer productivity as well. And the second thing is a Supersonic Subatomic. So actually, we made that name from the Queen song, Supersonic. And Supersonic means super fast, just a millisecond to start up. And small memory footprint, like I see, just 7 megabyte to memory footprint. And the other benefits you can develop and unify the imperative and reactive application. For example, you want to put in your Kafka cluster, integrate your backend application on Quarkus. You just put in the annotation like the add incoming add or Kafka cluster. And the other thing you need to implement your clustering, just the parse JSON format application data. And there are multiple open source projects to integrate, like deploy Kubernetes, Quarkus, and the OpenShift, and the Prometheus Jaeger for monitoring, etc. So, yep. So I think it's already time up. Okay. So yeah, just last word. So there are many application runtime to implement your serverless or microservice as well as cloud-native application running on Kubernetes cluster. But which the Quarkus maybe make it faster and smaller to manage maybe 100,000 your microservice application on the cloud, maybe more easy way. Thank you.